First question, crystals of covalent compound always have atoms as their structural units, molecule as structural units, ions held together by electrostatic forces, or high melting point. Now we know that covalent solids are formed by network or chains of atoms or molecules held together by covalent bonds. A perfect single crystal of a covalent solid is therefore a single giant molecule. For example, the structure of diamond, which consists of sp3 hybridized carbon atoms, each bonded to 4 other carbon atoms in a tetrahedral array to create a giant network. So correct answer for this question is atoms as their structural unit. Option A. Looking towards the next question. The edge length of the unit cell of NaCl crystal lattice is 552 picometer. If ionic radius of sodium ion is 95 picometer, what is the ionic radius of chloride ion? Now, in a NaCl crystal, we have Na plus as an ion and Cl minus as another ion. So the distance between the centers of this Na plus and Cl minus ion is given as R of Na plus R of Cl minus. That is the whole edge length is given as 276 picometer. Okay. Then we know the radius of sodium ion is 95 picometer and the radius of chloride ion is not known. So that is 276 picometer. Therefore, the radius of Cl minus ion is 276 minus 95, which is equal to 181 picometer. This is 276. Okay. So correct answer, that is the ionic radius of chloride ion, is 181 picometer. So correct answer for this question is option C, that is 181 picometer. Looking towards the next question, the coordination number of cation occupying a tetrahedral hole is. So as we know that the coordination number, also known as ligancy, is the number of atoms, ions or molecules that a central atom or ion carries in a complex or coordination compound or in a crystal as its closest neighbors. And the coordination number of cation occupying a tetrahedral hole is 4. So it's there in option D, and thus the correct answer for this question is option D. Moving towards the next question. If an electron is present in a place of an ion in a crystal lattice, then it is called. So an F center is a type of crystallographic defect in which an anionic vacancy in a crystal is filled by one or more unpaired electrons. Electrons in such a vacancy tend to absorb light in the visible spectrum, such that a material that is usually transparent becomes colored. So option D is correct, that is F center. Looking towards the next question. The second order Bragg's diffraction of X-rays with lambda is equals to 1 angstrom from a set of parallel planes in a metal occurs at an angle of 60 degrees. The distance between the scattering planes in the crystal is. So we know that the Bragg's diffraction law is given as 2d sine theta is equals to n lambda, or I can put the values like 2 into d is what you're supposed to find out, sine 60, which is given, okay, equal to n, that is 2 second order, and lambda is given as 1 angstrom, so it is 1. So when we solve this out, it comes out to be d is equals to 1.15 angstrom. So the correct answer among the given option is option D, that is 1.15 angstrom.